Okay, guys, today we are doing everybody's favorite thing in the whole world. We are doing word problems. Yay! Word problems. So, the excitement is just crazy right now. All right, gentlemen, last 2 minutes. Okay. For our viewers at home, everybody got a copy of the notes already, so sucks to be you. Okay. I'm so tired. Okay, here we go. Ready? That was so not okay. All right. I'm totally turning red. I actually feel kind of embarrassed that I said that out loud on camera. Okay, here we go. Okay. A trucker buys crates of apples and pears to sell at a farmer's market. The apples cost $6 per crate, and the pears cost $5.50 per crate. Each crate weighs 25 pounds. If the truck can carry 5,000 pounds and the trucker has $1,180 to spend, how many crates can he buy? Okay, so here we go. Oh, everybody get your calculators out. Let's do that on this set. All right, so here we go. Basically, what we want to do here is we want to set up a system of equations. We're given two types of information here. We're given cost of the fruit and then how much the fruit weighs. So we want to have two equations, one of which has the cost in it, one of which has the weight, okay? So clap if you agree. This is going to be a little lengthy, but clap. They agree with nothing. That's great. Okay. So clap if you agree that the total cost of the apples plus the total cost of the pears is the total cost of everything. Clap if you agree with that. Okay. So the cost of the apples plus the cost of the pears gives us the total cost. Okay. So if we know that the apples cost $6 per crate, one way that we could say that is it's $6 per crate times the number of apple crates. Does that make sense to everybody? If A represents the number of crates of apples, so let's go back here. The apples cost $6 per crate. I'm going to assume that A represents the number of crates of apples. Okay. How about, so if I want to set up something similar to that for pears, what would I do for the cost of the pears? If I'm using the information over here. The pears cost $5.50 per crate. Marcy?
5.50.
Good, plus 5.5, and again, we'll say that P represents the, whoops, sorry about that. P represents the cost of the pears. I'm sorry, P represents the number of crates of pears. Okay, Lydia. Total, yes. We want to find out how much of each.
Oh.
But that's good. Okay. Nicely done. All right, what does it say about the total amount of money that this trucker can spend? Good, equals $1,180. Okay, so we know that with a system of equations, there has to be more than one equation for it to be a system. So now we want to use the second piece of information that we're given. Each crate weighs 25 pounds, and the truck can carry a total of 5,000 pounds. So, would you all agree that the weight of the apples plus the weight of the pears gives us the total weight? Clap if you agree with that. Okay. Now, what does it say about, gentlemen, last 2 minutes. What does it say about how much each crate weighs in this problem? It says something about that. How much what? 25 pounds. So 25 pounds per crate, per apple crate, times the number of apple crates, plus 25 pounds per crate times the number of pear crates, gives us how much total weight can this truck carry again? 5,000. Good, so equals 5,000. Okay, so now we have our two equations. Okay, let's actually put them in a system here. 6a plus 5.5p equals 1,180. 25a plus 25p equals 5,000. Okay, how are we doing on questions so far? Okay, all right. What would be one way I could go about solving this? So we have some pretty big numbers here, but can someone tell me one way that we could go about solving this? Stacy? Okay, good. So do you have, which variable would you like to eliminate? Okay, so if we're eliminating A, then that means we're multiplying the top and bottom by which two numbers? You can pick. Anybody? So if I want to get rid of the A's, what would be a good thing to multiply the top by? Since we're using calculators in this, why don't we? Look, Lydia, go ahead. Good. Top by 25, the bottom by 6. But if we have both of them positive, is anything going to cancel out?
Oh, 6 we cancel.
Negative 6. Okay. All right. So calculator people, what do we get? Good. 150A. For the top one, we get 150A plus what?
137.5.
Good. P equals 29,500. And then on the bottom, we should get negative 150A minus 150P. 150, sorry about that. P equals negative 30,000. All right, so now when we add straight down, can somebody tell me what we end up with? Don't all jump at once. There's silence. I have stunned them. So what happens to the A's? Let's start there.
They cancel.
They cancel. Then we get 137.5p minus 150p. That is negative 12.5p. 29,500 minus 30,000 is negative 500. Okay, what is the last step in solving this?
Divide it.
Good. Divide by?
Negative 12.5.
Good. Negative 12.5. So calculators, we get P equals is 40. Good. Okay, so we know that we can afford 40 crates of pears, both in cost and weight. How would we figure out how many crates of apples we can? Okay, let's suppose that we don't use that necessarily, that logic. That's good, but Josephine? Yeah. Which equation do you want to plug it into? Yeah. So let's see. 6a plus 5.5p equals 1,180. And we're plugging it in for p. So 6a plus 5.5 times 40 equals 1,180. I think we all know how to solve this from here, right? So we should get that a is 160. Questions? Marcy? This?
Yeah.
Negative 150. Yeah, sorry about that. Negative 150 also. Other questions? God, these do go a lot faster when you guys already have the notes written out. It's nice. Fast is good. Okay, questions? Can I move this? Does everyone have it? All right, next. Everybody's favorite type of problem ever. Currents and wind and distance and rate and traveling. Yay. Okay. Let's just review really quick the distance formula. So there are two distance formulas that you guys have used up to this point. One has to do with the distance between 2 points on a graph. We're actually not talking about that one. We're talking about distance and how it relates to rate and time. Okay, so everybody work with me for a second. How many people ride a bike to school? Anybody? How many people walk to school? Okay. Okay, let's see. Work with me here. Let's suppose that I am walking to school, and I'm walking to school at a pace of 12 miles per hour. Okay. So I'm walking at 12 miles per hour.
That's a fast walk. Oh my.
I walk briskly. Okay. Now, let's suppose that I'm walking for a full 2 hours. It takes me 2 hours to walk to school. How many miles do I... That's good. 24 miles.
That's a long walk.
That's a long school walk.
Where do you live?
Yes, that is very long. Would have been faster to bike, I agree. Okay, but the point is, in this, 12 miles per hour, that represents a rate. I'm so tired. Did I tell you all when I was in college, when I got really tired, because I would have to stay up late studying and whatnot, I would just laugh hysterically. Just laugh. It's kind of embarrassing, but that's okay. So clearly that has not changed. We'll see how the rest of this set of notes goes. Okay, so here we go. 2 hours. Hours, that represents what?
Time.
Time. And then miles represent distance. So distance equals rate times time. That's what we want to use to help us through this example. And if you don't want to go through the last one, we can skip it. Okay, but we'll see how we do on the first one. All right, so we are keeping this in mind as we work through this. Does that look blurry to you guys? Okay, there we go. It's a little better. Okay, here we go. With a given tailwind, a plane traveled 3,840 kilometers in 4 hours. Shh. Christian. Shh. On the return trip, the same wind increased the plane's travel time by 1 hour. Find the speed of the plane in still air and its speed going to and returning from wherever it's going to and returning from. All right, so I'm going to, yes. Yes.
Find the still air, you subtract it from the and you subtract the difference from this one, or add to the second.
We will go through that in just a second. Hold on. Okay, so let's start by designating some variables here. Let's say that x is the speed of the plane in still air. Okay, that's one of the things that we need to find here. So the speed of the plane in still air. And let's suppose that since what our speed of our plane or our trip is going to be affected by the speed of the wind, right? So how many people have ever been walking to and from class when it's like ridiculously windy? And like sometimes it's raining and the rain is like horizontal. It's the worst. Okay, so if you're walking into the wind, it's going to slow you down, right? Whereas if you're walking and it's like coming behind you, then it's going to speed you up. So same concept here. We're going to say that y represents the speed of the wind. Or rain if you're really unfortunate. Those are not fun days to be outside. Okay, I'm going to set up a little chart here, okay? I like charts. They help keep me organized. All right, so it says here we have 2 trips. The first one is that we are going to wherever we're going. Okay. So we can assume that when we go on this trip, we are going with a tailwind. Oh, this is interesting. Okay. And then the return trip, that is with a headwind. Okay. All right, so here we go. We have our 3 variables that we need: rate, time, distance. Okay, now, again, if x represents the speed of the plane in still air and y represents the speed of the wind, if on our trip that we're going to this place, we are going with a tailwind, think about it this way. This is going to be a little bit graphic, but just work with me here, okay? So, keep in mind out of the gutter, Underhill. Okay, so a tailwind, if we're like flying and the wind is going into our tail, is that speeding us up or slowing us down? Speeding us up. So the rate would be the rate of the plane plus the speed of the wind, right? Does that make sense? On the return trip with a headwind, again, if we're flying and it's coming directly into our head, is that slowing us up or speeding us down? Oh my God. us up or speeding us down. Oh my god. I am so tired. Okay. Okay, so what would the rate be for this one? You all get what I'm saying. What would the rate... That's good. X minus Y. We're just going to brush right over that like it never happened. Okay, now... Except that it's on video, yes. All right. So it says here, all right, so with a given tailwind, the plane traveled 3,840 kilometers in 4 hours. Okay? So, what am I putting in here for the time? 4 hours for the trip going there. And then it said that on the return trip, the travel time increased by 1 hour. So what's 1 hour more than 4 hours? That's good, 5 hours. Okay, just checking. Now, on this last piece, distance equals rate times time. If our rate is x plus y and the time is 4, the distance would be 4 times x plus y. You're literally just multiplying these together. Now, if you want to put it as 4x plus 4y, that's fine. Same thing. Okay, how about this one? What's over on this side? 5x minus 5y, or 5 times x minus y. I'm actually going to leave it in that form because we're going to be able to do something really, really good with it. Okay, so here we go. Okay, how do I want to say this? We have some information in this problem about how many kilometers we're traveling in each direction. What does it say here about the number of kilometers we're traveling? 3,840. So the trip going to this place, which we found to be 4 times x plus y, equals 3,840 kilometers. Okay, so distance equals distance. Okay? Now, does the return trip change? Are we changing how much distance we cover here? No. So we want to say the next one, 5 times x minus y, also equals 3,840 kilometers. Okay? Now, you can either, if you wanted to go through and actually multiply those through, you could. But we can also divide the 4 out in the top one and divide the 5 out in the bottom one. I think that would be a little bit easier to do. So let's go ahead and do that. If we divide by 4 on that one, divide by 5, then we have a much easier system to solve. So the top one becomes x plus y equals 960, and the bottom is x minus y equals 768. And now we have a really easy system to solve. So what would I do here to solve, what would I do here to solve this system? Did somebody just say magic? I had a, no wait, this is really creepy. I just had a total deja vu with that response. Did someone just say magic? That was really weird. Okay, Ashley R. That's good. So we can add them together and cancel out the y's. So we get 2x equals 1,728. 728, my goodness. I had a break the first few periods. We were doing they were doing a worksheet first period, and then the last 2 periods we were reviewing for a test.
Would you like to have a break? We can take like a 5-minute break to relax a little.
Oh, that's
and
very
then we
thoughtful.
can come back to the notes.
Okay,
so that
thoughtful.
We don't have a fresh mind.
Shh. Stacy. Good. Good. So x again represents the speed of the plane in still air. So it's the speed of the plane in still air. What were the units that we were given to start out with here? Kilometers, and we were given hours. So this would be kilometers per hour. Okay, now how would we use that to find the speed of the wind, which is y? Elizabeth? Good. You have one that you would prefer to plug it into? Good. Okay, so x plus y equals 960, and we take that x, plug it in for x, so 864 plus y equals 960. And so when we solve this, we get y equals 96 kilometers per hour. Okay. All right, how are we doing on questions? Okay, we have another problem down here that we can go through if you guys want to. I can also give you the answers and see, you guys can try it on your own and see if you get it right, or we can just go straight to the homework. I'm going to leave it totally up to you. So, let's do it this way. We are recording, so it has to be an audio thing. Clap if you would like to jump straight into homework.
Yeah. All right.
Clap. All right. Encore. I get it. I'm getting your drift. Okay, I'm still going to do the other two options, though. Clap if you would like to go through this example problem. Okay, we don't have to do the other ones. All right, you guys have the homework listed up here, plus I'm tired. I think you all can see that. So, go ahead and start on that, okay?